true, but no.
In your class, it does not. In electronics, yes, we put something there. And so it's not a perfect conductor. But in your class, yeah, we can approximate it as a perfect conductor. So here's our problem. Diode, we want to find the diode current. This is a battery, and we got 2 resistors. Okay, so the whole idea comes from like knowing if the diode's off versus on, right? And so if the diode current is going like that, the whole idea is if the current is going in the direction of this, I like to see this as an arrow. If the current is in the direction of the arrow, then it's on. And so if it's on, then for circuits, there's no volts on the diode, and there's a diode current. Okay?
And this is why.
Yeah, and it functions like a wire. And so like I said, it's equal to a regular old wire. All right. So assuming that this is on, we're going to redraw it, but like that. Okay, so we know that there's no voltage, but there's a current right here, I diode, and that's what they want, right?
Yeah.
So, cool. So we got 8 here, we got 4 here, we got 12 here. All right, cool. And so I didn't realize, Javi, man, you're really good at this point, dude. I'm so proud of you. This is a short, and if you think about it, this would be node A. This would be node B, right?
Or A,
so this is between A and B. Oh, this is between A and B. This is between A and B. But if you realize when you move over, all of these B's become A's, and so you have A. Okay. So what happens is when a resistor is between the 2 of the same nodes, this is between A and A, you can effectively get rid of it because it gets no voltage. Because voltage between 2 of the same node is equal to 0. If I say V equals IR, right? V equals IR. When the voltage is 0, the current times resistance has to be 0, so that means I equals 0. So basically, a resistor is dead. And so I can just erase it. This is what I'm working with, okay? Another way of thinking of it is if I put energy, the current's just gonna go straight around the resistor because it has a free path to come back, okay? Why would the current take the traffic path through the resistor when it could take the free path? So that's the same thing here. It's the same idea. So I can short out my resistor, and I have that. I got 1 resistor, 12 volts on 1 resistor. That means that this resistor has to get all the volts. And so if you think about it, this short and this resistor are in what type of connection? Series connection. So if these are in series, this ID is the same thing that passes through that 4. And so basically, if I know the I through the 4 ohms, then I know ID. So I through the resistor equals I through the diode. I through the resistor is going to be 12 volts over 4. I equals V divided by R. 3 amps. Therefore, 3 amps is passing through the diode.
Do I need to test diode?
If you want to see if it's off, that's perfectly fine. So this is the diode when it's on. We'll do a quick test just to be sure that it's actually on and not off. So we know, I think I'll do it in green. When the diode is off, it's like this. All right. So it's trying to go backward, so I have to flip the polarity on it. And so the voltage on the diode is something. But the current through the diode equals 0 because it's stopping the current from passing. And so effectively, it works like an open circuit when it's off. But the voltage on the diode does exist, okay? It does exist. So if we want to assume that the diode is off, we just redraw the circuit with the diode in the off configuration, okay? So I know that the current through the diode is 0. This is what I'm working with. That's 8 and a 4. And so basically, that's the voltage on the diode, right?
Yeah.
Well, here's the thing. If I just erase these terminals, don't you see that the voltage on the diode is the same thing as the voltage on the resistor? So I'm just going to continue to erase it. That way students don't get confused when they see the extra leads. Now I just see it's one nice loop. Everybody's still in series. The voltage in the diode is the voltage on this resistor now, okay? And so if you take a look at that, how would I find that voltage?
Voltage divided.
voltage divider. So doing a voltage divider, I guess I'll do it in black. Doing the voltage divider, the voltage on the diode has to be the voltage of the source times the resistor that I want, divided by these two added up. 8 volts, right? And so we prove that it's 8 volts. But here's the thing. It's 8 volts, and it's that polarity. That's the actual polarity on it. And so here's the thing. My diode actually looks like this, right? If I were to put this polarity on this, let me draw it. I guess I'll put it right here. I'll put it in.
Why is that the polarity? Why is that the polarity?
Because that's the polarity that I used. Oh wait, hold on. You're right. My bad. My bad. Plus minus. It has to be plus minus, and then plus minus. You're right, Javi. Something that I always forget is that the voltage divider doesn't take into account passive sign convention unless you force it to. It's actually like that. Okay. It's 8 volts with that polarity. If I reverse it, I'd have to put a negative on one of these to account for that. So 8 volts with this polarity. And so if I draw my original diode, all right, if I want it to be off, the polarity should be like this, plus minus. Okay. Oh man, this video is terrible, Javi, man. I've been messing up all over the place. You want to know why I put plus minus? Because I put it wrong here. When it's off, the positive is on the negative side and the negative is on the positive side. That's the negative side generally. That's why this whole thing has been wonky. That's supposed to be the off condition. So when it's off, the diode polarity is supposed to be like that. But what I actually have, what I proved, is that it's like that. So this is what we call the on configuration. But then we also assumed that the current is 0. And so what we have is that the diode is on and off at the same time. Because the current tells me it's off, but the voltage tells me it's on. Yeah. If it's on and off at the same time, that's not real. Okay. Not true. And so we proved that it can't be turned off. Okay, it has to be turned on. When it's turned on, you look at it, the voltage is 0 across it, right? Wow. Javi, look, I really dropped the ball on this one. I wrote it backward over here.
That one's not good?
Yeah, no, I've been drawing it wrong.
Because it's plus to minus?
Yeah, the plus is on the triangle and the minus is on the little minus sign. Okay. That's the on configuration. Man, that's probably going to piss some people off. That'll be okay. I'll probably have like 8 more videos. No, I'm upload it. It's okay. Because it's just a simple fix. It's just a simple fix. Okay. The voltage being 0 actually kind of doesn't, it kind of neglects the polarity, but for the sake of consistency, I really want to have everything be right. So when it's on, that voltage is still 0 because a voltage under short is 0. And then the current we know flows in that direction because plus right here, that means it goes plus to minus. So the current actually does flow in that direction, which produces a diode current in the proper direction. The arrow has to be in the direction of the arrow. So for the on case, the current acts like it's on, and the voltage acts like it's on. If they're both on, it checks out. But in this one, the current acts like it's off, and the voltage acts like it's on. And that does not check out. Cool?
No. You see voltage is on?
Voltage
on top.
For this is on, yeah. I solved it. It proved it's on.
Yeah, on top. On the first one, voltage is on too?
Up here? Nope. Oh wait, well, yeah, it's on. As long as it's 0 with that proper polarity, it's on. So this is technically representing on. As long as this isn't negative or the polarity switched, it's on. Remember, for everybody, if you're in electronics, don't heat this. If you're in electronics, the students in electronics have to remember this, that the voltage across the diode is 0.7, and that's going to be a completely different analysis. Well, not completely different, just very similar. But there is a bit of understanding that has to come from this 0.7 volts, all right? This is for basic circuits where diodes are ideal. Ideal cases, diodes act as shorts and opens. But in electronics, they act like diodes where we have turn on voltage. That's not what we're considering here, okay? So if you're an electronics student, please, I don't want to say forget everything that you learned just now, but the concepts are the same, but the problem would have a different answer, slightly different. All right, it would still be on. It just wouldn't have 3 amps. It would be a little bit different, okay? So with that being said, thank you for your time. I hope this helped.